Hey guys, hi, how are you doing? Sorry for the delay, but Twitch thought it would be funny to release a new stream manager, and it confuses the crap out of me. Can you guys hear me? Oh, obviously you can. I'm fine, thank you. Thank you for asking. I'm good. This will be fun today. I hope so, at least. I hope you guys can get something out of it. Oh, Mr. Tree is here. Hey, how are you, man? It's funny, this dashboard only shows that there would be one viewer, but already 2 people in the chat. Technology. Yeah, sure, my pleasure. Disclaimer up front, this today will only be a little bit about Python, mainly about getting everything set up for general development. You can also use the stuff I'm showing you today for the web development part. Some of you may want to put a front end down with web technologies on top of your Python stuff, so it's more of a general tutorial today with a little bit of Python. So we will basically go until we are able to debug Python code, and I will also show you how you can use Jupyter notebooks in VS Code, which is quite nice for prototyping and stuff. And I guess for much more, I'm new to Jupyter notebooks myself, but yeah. So I'm learning along with you guys, except this guide or tutorial today, because yeah, that's what I have to set up for all my development with web stuff. Sounds good. I'm guessing there are some general rules and structures we should follow when coding in general. I have no knowledge about that at all. Yeah, that's right. You should have a decent workflow. It's also a little bit of thing of what you like. So mine is just recommendations, some parts of what I'm using, not all of it. And it's I made sure that everything is as free as possible, that you don't need to buy shit, but at the same time that you also have enough capabilities or features like private repositories. For example, we will do source code versioning with Git. I will show you later what that is all about in case you never heard of it. And we're using a free online service called GitLab for that. You should have created an account for this, hopefully. And on this you can save your source code and have it versioned. And yeah, it's a totally free service. It's what I'm using myself. The only difference is I have my own GitLab server running on a privately rented VPS. You can do that also, by the way. GitLab is totally free to use for your own purposes with the community edition, which has more features than you will probably ever need. So it's really cool. But I will show you. Great. Dashboard still shows 2 viewers. Okay. I have no idea if anybody else is watching this live stream right now. I would be happy to see a short chat message of yours. I would like you guys to tell me who of you is following along, so I know how many hands I need to see before I know that I can continue on. So if you're following along, leave me a quick message in the chat, please. Nice. Good to hear, man, that you're already prepared. I wouldn't have expected anything else from you, to be honest. Okay. Yeah, so I guess it's probably us three. Nice little round. I like that. So if you have any questions, drop them in the chat. I will try to keep my eyes on it and answer everything as best as I can. Cool. So what we are going to do today is we will set up Visual Studio Code, which is a free open source IDE code editor, which is super extensible. I like it very much. Recently I heard that VS Code is now under the top 3 editors used by Python developers, so as a good choice for sure. I chose it mainly because it's fast and it's extensible and it's completely open source, so I like that a lot. And it's quite bare bones, so there's not a lot of stuff you don't need. Then second of all, we will use Anaconda to manage our virtual environments. What that is, I will try to give an explanation later. We use Git for source code version control, and GitLab, as already mentioned, and CopyQ, which is a tool that I'm actually not using myself because I'm on Linux and it's not available for Linux. I'm using something else, but it's very similar to that, and it's basically just a clipboard manager. Maybe you guys already used something like that. I think that's one of the most underrated features you can have on your PC, because copy pasting is what you do most of the time when coding, really. So that's just simply easier. Okay, let's start with Git actually, because assuming you already have installed Visual Studio Code and Anaconda. And first of all, we need to set up Git so we can use it for versioning our source code, and we will do everything step by step, so no worries if this all doesn't make sense to you. So first of all, you should have a program called Git Bash if you search in your start menu. Please open that up, and a black window will appear, a console window. This is one of the first things you will need to get accustomed to that is working in a console. So we need to generate what's called SSH key pair for everybody of you. That is needed to securely transfer your source code onto the GitLab server and to pull it down. It's basically a key pair for encrypted data transfer. So to do that, you enter the command ssh-keygen, and this should autocomplete using the tab key to .exe, and you just press enter, and it will ask you guys where to save the key file. Just leave the default, press enter, and then it will ask you if you want to define a passphrase. And I don't set a passphrase here. Basically, it's a password for your key. Whenever you want to use the key for the first time, then you will have to enter this password. So if you don't want to add a passphrase, just hit enter again. That's what I'm doing, and again. So now we have an empty passphrase. That's good for me here for this tutorial. So after that, we need to set two configuration parameters for Git, so it can sign your code commits. Again, whatever that is, I will tell you later. For now, it's just entering this command: git config -- global user.name, and then your name. You can use the whatever these called in English. I can't remember. And you send that, and then git config -- global user dot quotes. Thank you. Email user.email, and we set the email. I made a new email account for this tutorial that's not used for anything else. protonmail.com. Nice. Now that's all set up. So what Git has done here, I don't know, do you I hope you guys can even read this. That email address is visible to others under circumstances, so I wouldn't use something you use for exchange accounts or something like that. I think there are privacy settings in GitLab, but best practice would probably be to make a dedicated email address just for that. But you can change that at any time. Just repeat the command with a different email address or different name, whatever, and it will just save it. Because all it does actually is writing a file in your user profile folder. I'm here on a evaluation version of Windows. That's why I have such a strange username here, because I'm not a Windows user in general. And it writes this .git config file here. If we take a look at this, you can see here's the information that you entered on the console. It's really the same thing. You could even change it in here. Okay, and the second thing that was created is this .ssh folder. In here is this newly generated key pair that we created with this SSH keygen command. So now that should conclude the Git setup. Next up, we wanna take a look at GitLab. I already logged into this account. For some reason, I didn't get the confirmation email so far, so that's why I have the strange message on top. And the main reason why I chose GitLab is because you can create private repositories in there. A repository is, imagine it like a folder or like a project folder where your source code lives in. And you can create an unlimited amount of projects or repositories in your GitLab account, and they don't have to be public. On GitHub, they have to be public, meaning everybody can view the source code. So I click here on Create a New Project, and this mask here open up, and we will create one. Let's say tutorial. So there is a project URL. That's basically the URL under which you can open this project. And here you can choose private or public. If it's public, everybody can see it. You can keep projects private and then invite others and give them access, grant them access to your project, so you don't have to make it public. Okay, that's that. I just click Create Project, and now we got our first repository where we can save source code into. And like me, you should get a warning on top of the screen where it says that you cannot pull or push source code into the project until SSH is set up. We have to do that right now. We will use the key pair that we generated with the git bash and connect it with the GitLab server. For that, you go to, you click on your avatar in the top right corner and you go, I think it's settings. And in the settings, there is in the left-hand menu a section called SSH keys here. You click that, and here we need to enter the public part of the key pair. So I don't know if you guys know anything about encryption with asymmetric key pairs, but how this works basically in a nutshell is you have a private key, that's this one. This one, you should never give that out to anybody or they get access to everything. You use this key for, and then you have this pub file. This is the public key, and this is what you give out to others, so they can encrypt messages for you that only you can decrypt then later. And this is what we need to open right now with any text editor that you want. So the IDRSA pub file. And I just press Ctrl A to highlight everything, select everything, copy that, and close this file here. And we paste it into this thing here, like so. And there is a tile that is completely up to you. What you put in there is just for you, so you know what that SSH key is all about. You can add multiple SSH keys if you have one for work and one for your private stuff, for example. And we add this one. So if I used a different email address than that I used for creating the GitLab account, do I have a problem? That shouldn't actually matter. I never tried it, but to my understanding of Git and GitLab, that shouldn't matter actually. Okay, now we got the SSH key, the public key in here, and that should get rid of the error message. So I get back here to my projects, clicking projects, your projects, got the tutorial, clicking this here. Okay, now the error message is gone, and can't get rid of this also. Stupid email verification. Oh, won't close, that's nice. Anyways, so what we will do now is clone this repository. So imagine it like copying a folder from a server from the internet. So you have a local copy of this project, which is currently empty, but that's totally fine. We will fill it up later. And for that, we need to clone it. But before we can clone it, I decided to do a little change in plans, a little plot twist here. We will download and install another tool called SourceTree, which is a visual tool for working with Git repositories locally on your computer. That is way nicer than with VS Code, which is also able to do that, but SourceTree is just more is easier to use. So go and search for SourceTree on Google. You should get the first search result, sourcetreeapp.com. Click that one and click download free on the top right corner. And yeah, we have to agree. here to the privacy policy and stuff. Of course, you guys can read it if you want to. Okay, that's that. So we execute that. We will need to create an account at their service, but it's free as well. It's a little bit of a drag because you can't really have a nice workflow without registering some kind of software nowadays. If you want to do this in a semi-professional way, not that I'm aware of at least, or you have to use tools which are just not as easy to use. It's doable, but it's also not very nice. So, okay, what do they need from me here? Did you guys find the download and got it downloaded? And are you guys on the same page with me? Okay, cool. So we will need to create a new one, create one for free here. We don't use Bitbucket. Oh wait, let me check. Is so the Bitbucket create a good? Oh no, it's the right one. Yeah, Bitbucket thing. I think that's another service, just like GitHub or GitLab, but we won't use that. Okay, needs an email. And we need some password. Oh, I should select all bridges. Okay. Nice. No, please, no newsletter. I hope I didn't get a typo in here. Ah, god damn it. Okay, now it should be good. I don't like that I don't have a confirm password field here. Okay, I will look at my main computer for the email. Oh, nice. The GitLab email arrived in the meantime. Verify email. Continue. Yes. Yeah, I can save that one here. No. Okay, that looks good. I will just quickly confirm the GitLab account as well. Nice, done. Cool. So now we should be able to that's nice. Now how do I continue? Do I have to use one of those? Okay. I just chose the Bitbucket option. Let's see if this works. Okay, let's try. Yeah, that worked. Okay, it's waiting for the login to finish. Almost done. What do I need to do? Create a unique username. Ah, okay. Underscores, no dots. Cool. So I got my username. I really don't care what you want to know from me. Oh. Yeah, of course. Something else. Oh shit, there was a skip button. Okay. Great. I'm already highly yeah. So let's try again, I guess. Skip? No. The integration is misconfigured. That's great. Dashboard overview. Back. Okay, I would just try this again, maybe. Oh, now it works. Okay. So if you guys have the same problem, just go back here and click that Bitbucket option again. Hopefully you will have... It worked for you guys. Okay, cool. Yeah, if you repeat the processes, it seems to work for me. I hope so. Yeah, okay, nice. Cool. Yeah, it should detect Git here installed already. That's awesome. We don't need Mercurial, or however that is pronounced. That's a different type of source control. What do we have under advanced options? Configure automate by default. Configure global ignore. Yeah, okay, that's good. So check the first option here under advanced options. That will make sure that your the line endings are consistent. That's important if Windows users and Linux or Mac users work together on the same project. So because they use different control signs for carriage return or line endings, and SourceTree will take care that these are automatically converted to Linux or these LF line endings, and vice versa if you check it out. So it shouldn't get screwed up when multiple people with different OSs work on it. Okay, what's that? Before we finish, take a moment to configure these settings, set global options details for Git and... Yeah, okay, that's already done. So we don't really need to do this. We can check or cannot check it. It doesn't really matter. I don't want to send them usage statistics. So just do it like that. And do you have an SSH key you would like to add now? Yes, we want to add our existing SSH key, and for that we will browse to our user folder, which is under this PC, C, users, your username, SSH. Oh, they are working with putty files. Are you kidding me? Guys, why not just use the standard stuff? Yeah, that's the risk when you change plans in the last minute. Okay, we'll cancel this here and see if we can add the other kind of key later on in the tool itself. So okay, on the tools, create and import SSH keys. No key, load. That's probably one of the... Yeah, I really don't like that. Sorry guys, I should have looked that up beforehand. They only use the stupid putty keys. SourceTree general or it's an RSA key. Let's see if they setting up SSH key. So here they... maybe we don't need to add them. Let's see what we got on their account. Do they have... They have GitLab here. Okay, we will have to try this. Oh, that's maybe a good way anyways. SSH. Yeah, I think we will do it like that. Yeah, we will connect SourceTree with via personal access token. That should work fine. Okay, guys. So go to edit account, and then select in the hosting servers GitLab. And here we have the personal access token is the only way anyways. And now we need to create one. Let's see. Oh yeah, that's the documentation. I think I know that from the top of my head where we need to go there. In your GitLab account, you go to your profile settings, top right corner, avatar and settings. So what I'm going to do now is create an access token, and the access token is basically another way to connect to the GitLab server and authenticate. It's kind of similar to the SSH stuff. We will still keep the SSH stuff set up because that's useful in the future probably for you guys, so that's always good to have set up. Okay, we need something here for a name. Go with SourceTree. We're basically allowing the application to use to access our GitLab account. Okay.
You're listening to Ceballos, live from
what do we need to grant? Oh, I have to look this up quickly. Which one is it? Personal access token. Choose desired scopes. Okay, they don't describe this here particularly for this thing. So what we will need is API for sure. User profile probably won't need. Repositories, yes. And also write repositories, otherwise we won't be able to. SourceTree app won't open for you. Oh, Insta crashes. That's great. Yeah, guys. If it crashes, maybe you have in case you have a virus scan or something, third-party virus scan enabled, you can temporarily disable this one and okay, stuck process. That's the other thing. Yeah, maybe your virus scanner is killing it if it still crashes. It's back now. Okay, cool, nice. Okay, is everybody here on the same page as I am? In case, yes. Art design, you as well? Yep, okay, cool. So I will go with API, read and write repository. Read registry, we don't need registries. So I generate that personal access token. There it is. So now you could steal mine, that's great, right? Okay, so where can I enter this one? Okay, so it should be here under refresh personal access token then, and then we need to enter the username. What was my username in GitLab? With dot? Trading Peter 7777. And here should the access token go, not your normal GitLab password. Okay, hopefully. Okay, cool, that worked. You click under Add an Account here in the main screen, and this opens up. You choose GitLab for the hosting service, and then you click Refresh Personal Access Token. And then you enter your, and then you oh, God damn it. Yeah, then you enter your trading, your username for GitLab, and you enter the access token you generated. So not your normal GitLab password, but the access token. So, is it working? Okay. Cool, so let's try this. Okay, cool. So now when you click that account, you see that one tutorial repository that we created. And now we want to clone this. So let's click this and click on this little clone link here. Now we get to choose a destination where we want to put a local copy of this project. I would just leave it at Documents Tutorial. That's fine for me. You guys can change it if you don't like that there. It's on the advanced. Yeah, check out branch. We don't need that for now. Okay, and then we click clone. Okay, nice. Man, it has been years since I used SourceTree. looks a little bit different, but kinda the same. So should be fine. Okay, cool. Now if we look in the File Explorer, Windows Explorer, we see here under Documents or wherever you cloned your project to, this tutorial folder, which is empty, of course. And now we will get to the funny part, namely using VS Code. So let's close or minimize this stuff here for now. Close this one, close this one. Okay, cool. Now we open up Visual Studio. And I will give you guys a little rundown of the barebone editor and the basic commands that you need to remember to be efficient in there. So yeah, Visual Studio Code is super nice. It's the nicest code editor I've used so far, and I use quite a lot. You get the main menu. You got the left side panel. These are the more important menu points. Most of the time you won't use the stuff up here. The first one is the File Explorer. If you click to expand or collapse it, and here you see all the open files or folders of your project. The next one is a search through your whole project. It also has replace capabilities here. So you can search and replace. You can search matching case or the whole word. You can even use regular expressions if you're into that kind of stuff, but that's a science for itself. We won't get into that today. Excuse me. Next is source control. Visual Studio has Git integration built in, so you could also do nearly everything that we will do in SourceTree with Visual Studio. If you prefer that, it's just not as visually appealing and it doesn't give you as good as an overview as SourceTree will. So we won't use that very much, but we will use the debugging panel. That's this little bug here. Here we will see where we are in the code, what values the different variables have, and so on. And then there is the extensions panel, and here we will install some stuff right now. The extensions panels is what the name suggests. That's a marketplace of extensions, free extensions for Visual Studio Code, and there are so many for nearly everything you can imagine. And we will go with the Python one, and it probably is right on top for you guys as well. If not, then just type in Python in the search field and click this little install badge on the top right bottom right corner of the one that is from Microsoft. There is the author here, and Microsoft is the one we need with 13.3 million installs. Just click install and we wait a little bit. Oh boy, my VM, this virtual Windows is so slow. So far so good, that's right. If it would install for me. Now it's done, nice. Okay, there is a lot of online resources like top 10 Visual Code extensions online for you guys, so you can check that out. There is some nice stuff. If I come across anything that would be useful for us, we will install it later. But Python should be all that we need for now. So we can close this down here by clicking this button again, so I have more space. And next up we will open our project folder. So go to File and Open Folder. And it should put you guys into your Documents folder by default. Double click the tutorial folder and select folder. Visual Studio Code reloads and brings the project up. Nice. So in the File Explorer there are these little buttons here where you can create a new file, new folder, refresh the view, and collapse and expand everything. So it's good practice to put all the source code for your project in a folder, in a separate folder. I like to use the short word src for that. I do that because on the root of this folder, most of the time I add stuff like readme.md file or something like that. So all documentation stuff and such goes outside the source code folder, and inside the source code folder we put the actual source code, so that's nicely separated. And we'll do that here just so we have something in here. Let's do main.py. So click the source folder and press this little guy here and add this main py file. Okay, now you can see Visual Studio Code works with tabs. You can drag those tabs to different places, reorder them however you need to, and you can drag such a tab to upper side, and the highlighting shows you where it will split the window. So if I put it to the right side, it will create a split view. I can get that together again by pulling the tab over can do that on the bottom and on the right side. Oh, come on, like that. So you can arrange that however you like. It's one of the most intuitive editors that I've come across so far in terms of how this works. That's important to know. And then there are two shortcuts that you should remember. The first one is Control and P, which brings up this little search box where you can quick search for a file in your project, like the README, and then just hit enter and it will open up that file. If you have big projects with hundreds of files, this is absolutely crucial to know. Control P. Oops. The next one is Control plus Shift plus P. That is to execute the command. Control Shift P brings up this little search box with actually every command that Visual Studio Code knows. So you just hit Control Shift P, enter something like, I don't know, zoom, for example, and then here, editor zoom in, press enter, and it zoomed in. If you open up the search box again, it will automatically have the last used commands on top, so you can just execute them again, either by clicking or just using the enter key. So, and next up we wanna yeah, what do we want to do next? There's so much I can't even decide actually. Next we wanna maybe change some shortcuts, at least one or two. So there should be the shortcut to move a file, a line in the source code, and one to delete a whole line of code. That's the two that I need the most. I will show you what I mean, but first we need to set them because I don't know what they are by default. So we go to, where is this? Oh, just use Control Shift P and then do, I think it's keyboard key mappings, yeah. Preference key maps. Preference key maps. That's what we need. No, that's the wrong one. I'm sorry, guys. I'm not used to the English front end. Key. Open keyboard shortcuts. That should be it. Then, yeah, that's the one. So Control Shift P, search for key, and then select Open Keyboard Shortcuts. VS Code is super duper configurable, and I want to set two. One is delete a line. Yeah, this one. I just double click here on the, no, I think I need to click this little pencil here, and then I can enter a new one. I personally like to use Control and the backspace button for that. Yeah, that's cool for me. Just confirm this with pressing enter again. And the other one is move line. Move. Okay, it's Alt by default. I like to change this to Control. So double click. This is move line down, so this would be Control arrow key down for me. and move line up, control, arrow key up, and enter again. Okay. And now if I go back here into my README file and I put my cursor on this line 2 and I press and hold control and use the arrow keys, I can move around the line. So that you will probably love this when coding, because you have to do this a lot. Hi Sniper69, how are you doing? So, and you can also move multiple lines. Just select them, partially or as a whole, doesn't matter, and then you can move the whole block. So that's super duper useful. And the other one is deleting a line by control backspace. If you call that crap, then you can just control backspace it. What's up? With what do you need help, Sniper? I hope you can describe your problem in easy words in the chat for me. So yeah, that's this, and then there is another shortcut that is Control F. Control F is, you probably know that from browsing in Chrome or Firefox or whatever. Control F is the standard keyboard shortcut for searching. This brings up this little search box here on the top right. The main difference between this one here and this one is this is only the current file and this is in the whole project. And by the way, you can if you want to search in the whole project, you just would use control plus shift plus F, search whole project. You need to do a rock paper scissors game in Python. Okay, I'm sorry, Sniper, I can't get into that. That's out of the scope and of this live stream right now. I'm sorry, man. So, and then there is Control plus F, search in current file. Yeah. So that's probably the shortcuts that I use the most. Oh yeah, and oh no, I lied to you. I think no, we need one more keyboard shortcut, and that would be duplicate. I think it's section. Yeah, that's probably. Yeah, Control S. That's a good point. Yeah, Control S is the most important shortcut. Okay, I think it's duplicate selection. The problem is if you have to set up once, you forget how what the stuff is called, and I use Control D for that. So let's try if that's the right one. Yeah, it is. So now, if you set this keyboard shortcut here, duplicate section, I use Control D, use whatever you like. You can just put your cursor on any line, hit Control D, and it will duplicate the line for you. And if you do a selection, like so, and you hit Control D, it will duplicate that whole section. Really useful stuff. Okay, nice. So we got that. So now we will do a little bit of a side tangent, and we'll take a look at our clipboard manager. There is an extension for VS Code, that is also a clipboard manager, but in my experience, it is useful to have a system-wide clipboard manager, not one that only works in VS Code. That's why I'm going with this one. So you should have this one probably already running. It's on the top, bottom right corner of your screen under those little icons. It should be this little scissors symbol. And if you click that, you should open this main window here, which has already collected the stuff in your clipboard. Obviously, if you're live streaming like me or somebody is looking at your screen, be careful with what you have in your clipboard, because it will of course have passwords and stuff in there, like my access token here. Yeah, but as long as you're coding in your mom's basement like me, no, not it's my own basement at least, but yeah, then you're fine. So, and I wanna configure the keyboard shortcut for this to bring the context menu up for that. And for that I go to File, Preferences, and in the Preferences there is this shortcut section, and I happen to know that it is Show Tray menu, as far as I remember at least. And I will add a shortcut for this, and I would like to use Control Alt V instead of Control V for pasting. I would use Control Alt V for bringing up the clipboard manager. So there is only one finger different for the usual shortcut. And I apply this, and okay, close this down, and let's look if this works. Control Alt V, yeah, and it brings up this context menu. So now you can copy something with Control C as usual, and then you can go somewhere and use Control Alt V to open this and switch between other stuff like this link. Now I got it in the clipboard, and then I can Control V again and go back to the original line that I had first and paste that in. And yeah, that basically gives you superpowers, because now you can copy multiple stuff and paste multiple stuff somewhere else. I'm sometimes actually really collecting. Yeah, it's really useful. So I'm actually sometimes collecting stuff all at once. Control C, Control C, Control C, and then I paste it all in one go at the right place. That's really, really useful. But you have to be careful with passwords, of course. Okay, so let's get rid of this stuff. And Control S for saving. Yeah. You can see on the little dot on top that this file is not saved, and as soon as I hit Control S it will disappear, so you know it's saved again. So let's go over to the File Explorer again. On the top you see the open files, and down here are all the files. Okay, yeah, and now we will put the first source code, which is this README stuff here. If you didn't enter this stuff in your file, that's okay. Just type something in there so you have something. Okay, I missed the part. I missed this part as the little one got out of bed. We'll watch later. Oh yeah, that's fine. With the clipboard manager isn't a deal breaker if you don't have that right now. Okay, so make sure you have something in your README file or whatever file. It doesn't really matter. And then you go over to the SourceTree window, and hopefully it will update. And here we see the files that we created. So, and how Git works is probably something I should describe to you a little bit better. So imagine when playing a video game and you get to a certain stage, you want to save the game, right? Git is basically that. Git takes snapshots of your code at a specific point in time, and you can go back to these points. You can look up what did change. You can try out different ideas and switch between them. And we will do this all of this a little bit by example, so it sinks in what I mean with that. And every time you quote unquote save the state of your source code, we are creating something that's called a commit. And this commit contains all the changes on the source code, as well as what files were added, what files were renamed, modified, or even deleted. So you can even get back deleted files if they were committed at a later point. It's like a time machine, really. And it also helps to find out what did you change 2 weeks ago in the source code if you by accident deleted something that you all of a sudden now have use for it. So to create a commit, there are really two things we need to do. First is we need to stage the files and the changes that we want to include in the commit. There is the section unstaged files. This is simply all the changes that SourceTree can see in the Git repository. And on top here is the section for the staged files, and everything that's in the staged area will be added to the commit. So we can also do we can also partly commit stuff. We don't have to do everything. So let's add the README. When I click this, I can see here there are the file contents, and I can use this little plus button here to add it to the staged section here. That means it will be added to the commit. Our src main py file is empty right now, so I don't even bother committing that right now. I don't put it in the staged files. And yeah, the second step is to put in a commit message, something that hopefully describes well what you changed. Something like that. It's a little bit of a science to formulate to come up with good commit messages. They shouldn't be too long, but they should clearly state what you were doing. So in case you need to find out what went wrong at a later point, in what commit you have to look. So yeah. If you're only a little bit like me, you will probably always use very generic, unuseful commit messages. The last step is to commit this here with the bottom right button, and that's it. Now the file is gone. Now we can take a look at this in the history section here. The left side menu. Here we see our first commit with the commit message, and here you can see the name and the email address. That is exactly what we configured previously for Git with this git config global command. So every commit has a unique ID here. And this can be used to reference certain code changes to somebody else who's working on this, so he exactly knows what commit you are talking about. And on the right side, we see these were the files that we added to the README file. Yeah, And now what's important to note here is this little master word here. Oh no, SourceTree doesn't really like your PC, it seems. Okay. So I personally use a different tool. You can try that out if you want to. We can't get into this here. Its name is Gitkraken, and I would have preferred this a lot over SourceTree, but the problem is the free version doesn't allow you to work with private repositories. So you would have to buy it for the private repositories. That's the only downside. But this Git client is, in my opinion, way better than SourceTree. Yeah, you can do a Google search. There are some other clients as well. Sorry, I can't give you any better recommendations like now. But you can commit. I guess I can show you that here as well. Okay, you have another PC anyways. Okay, so you can also try here to do the same stuff. In VS Code there is the section, and here you can also see the changes, and you have this plus button to stage changes, and then you can enter a commit message here and commit it to the Git repository. So that works as well if you want to, or you watch it later. Okay. Yeah, this master stuff here. Master is the name of the so-called branch we're on. A branch is in Git like a timeline, and you can create multiple branches or timelines and do different stuff on them. So let's actually try this out so you get a feel for what I mean. So we'll create a new branch here, and we will call it, I don't know, a stupid idea. And we go create branch. So now we got two branches here, the master branch and a stupid idea. And currently this a stupid idea, that branch is checked out or active. You see that by this little circle here. And in VS Code we should also see, yeah, here in the bottom left there is the branch that we are currently on. You can even click this and you get this little window with the available branches, and you can also switch them here. So SourceTree is really doing the same stuff as Visual Studio Code and vice versa. The only real difference is this view here with the history is way nicer than what you have in Visual Studio Code. That's really the only reason we're using SourceTree right now. Gitkraken is even better when it comes to this stuff. So yeah, that's that. So now we are on the stupid idea branch, and if I now go on and make some change to this file, like that, and I save this, and maybe I even add another file here. Destroy Bitcoin, for example. Probably a stupid idea. So now we got these two changes here, and if we now go back to the SourceTree and wait until this updates. So now we need to, I think we can also click this one here. Yeah. So now there is the uncommitted changes. That's basically the same as we see here under file status, but we keep the file status views for consistency. I think you can do the same stuff here as you can do here in the file status view, but here it's a little bit bigger. So, and here we can see I changed this README file with these 2 lines, and this is a new one, right? So now we stage, oh yeah, I staged the main py file. I will unstage this by using this little minus button here. And instead stage those 2 files, 1 and 2. Added a stupid idea. Okay, and now I commit this. So now we go back to the history view. And what we see now is there is 2 branches with 2 commits. And now to make really clear what branches is all about, if I now want to continue with work on the main project. Okay, art design got another error. Make sure your head is not a commit and a branch. Stupid idea cannot be created from it. Are you in SourceTree right now? Did you get it working, or are you in Visual Studio Code? Okay. You tried to create the branch in Visual Studio Code then. Yeah, so for that you would, let's see, you were here in the master branch. Let's check that out. Like here. So when you want to create a new branch, you probably did that. Where did you do that? Probably down here, right? Okay, so I would make sure that you are on the master branch, and then you click create new branch. You give it a name. I have to choose another one, and then it should put you on this new branch, another idea. Is that what you did? Okay. It's possible that maybe SourceTree somehow corrupted the repository when it crashed. So I would suggest you do the following. You go into the tutorial folder. And here there should be a hidden folder. I think you have to enable hidden items. I have SourceTree. Should I maybe close? No, that shouldn't matter if it's open or closed. But you can try to commit in SourceTree. Anyways, that's a good tip to know. As soon as you have a Git repository on your drive, this repository will have this hidden folder called .git, and in there is all the information Git needs to know about the repository. So if you basically delete this folder, then you got rid of Git for this project, which is totally fine. It won't destroy anything besides the Git history and all this stuff, but your source code itself would still work. Just as a side note. Okay, let's see if, yeah, so SourceTree updated for me. Here with the first branch that I created. I will get rid of this. Right click and delete branch. Can I check? Okay, I cannot delete the branch because it's the currently active branch. So I have to switch back to a stupid idea first. And now I should be able to delete this one. Okay, back on track here. So we got this master branch and this stupid idea branch. And the stupid idea branch is the active one. So if we go back here, we have this state here. Let's clean up here a little bit with the ideas file and the readme file. And that is now on this branch. And now let's say I want to make oh yeah, good night. Now we will try out what happens if we want to do more work on the master branch, right? So imagine you got here something you were just trying out, but you weren't really sure if you want to keep it in your project. So we did this on a separate branch where we added this file and modified a little bit on readme. And now if I go back to the master branch by checking it out, so I right click here and I select checkout master. Now I was traversing back in time basically and traveling back in time, and now I'm back on the master branch. And if I go into my Visual Studio Code, I will see here that ideas MD is deleted because at this point the time, the state of the source code, it didn't really exist, right? So here you see the file is gone, and also this modification of the readme file isn't any longer present. And if we go back to the stupid idea branch, check that one out. Go back here. Now our file is back and the readme has the missing line. So, and once again, check out master. And now we go here into Visual Studio Code and we add something here. So now we really diverge from the other branch. What did I miss? Yeah, control.s for save file. Save that, and now we go SourceTree, file status. Here is the change. Stage that. Added shortcut for save file. Commit this. Okay, now it gets interesting because now we see that here we have this common starting point for both branches. And we branched off with a stupid idea, and master is now ahead of a stupid idea, right? So now we can see that what I think it should now be clear that the branches are separate versions of your source code, and you can try out stuff. And if you want to bring something that you worked on in a separate branch into the master branch, which you should always use as your main branch, you can merge those changes into the master branch. And I just have to figure out how this works in SourceTree, I guess. Yeah, here. You just do a right click on the branch you want to merge, and then you click merge a stupid idea into the current branch. And then we do yes, confirm that. And now it will try to merge the source code together. And sometimes this will work and sometimes it won't work, and we will need to resolve conflicts, as we have to do right now because I changed the readme file in the master and in stupid idea, and it's a little bit confused now what it should keep. So let's close this. Oh, it didn't. Oh yeah, there they are. Okay, let's see, where are the... Ah yeah, here are now the... Here's the conflict, right? So here we can see this is what I have in the master branch, or the head. The head is the name of the newest commit, and here is the change from the branch called a stupid idea, and it wants to know what do you want to keep. So I can just edit this like text if I want to, and get rid of this marker here and this marker and this marker to keep everything. Or you can also click those little links here. Keep current change, keep incoming change. The incoming change would be this down here, and the current change, then it would only keep this here. And if I accept both changes, then both lines stay in the file, and I can clean everything up. Save that, and now this conflict is resolved. This could, of course, be could be a problem in multiple files. So you would have to go through them one by one. And now SourceTree should be, yeah, now there is this change here, so we have to commit stage this resolved conflict. I hope that's how it works in SourceTree, really. Git Kraken does this a little bit more intuitively. And now we should be able to commit this. Yes. Yeah, exactly. That's what I'm looking for. So this is now basically a merge between two branches is also a commit, or results in a commit, which brings everything together. So now here, see that we have both the lines in here and the new file. Down here I can keep the commit message or change it if I want to, and then I commit this. So now back in the history, you see we merged the stupid idea into the master and even resolved the conflict while doing so. Most of the time, if you think a little bit ahead and you try not to work on the same file in multiple branches, you won't have those conflicts, and it will be a matter of right-clicking and merge, and you're good to go, and that's it. And it will do the merge commit for you, and you're done. So this was a little bit of a worst case scenario, really. So yeah, is that clear so far why source control is an important factor in coding? It definitely needs a little bit of getting used to. It's not the easiest thing in the world, but it will save your ass like a lot of the times. Because if you fuck something up, or if you just need to experiment with something because you're not sure of how to solve your coding problem, working on a separate branch while keeping the main code that you know works and you want to keep as is clean is absolutely priceless to have. This gets even more important if multiple people work on the same project. Yeah. Yeah, that's definitely something to get used to, the interfaces, for sure. Just experiment and yeah, keep at it. Read up a little bit on how Git works. That helps definitely, but it separates the real coders from the not real coders to have good version control. That's just a fact. Okay, and this is all happening locally right now. There is nothing on GitLab yet, but we already connected, or we pulled this repository from GitLab, and we will push it up again so that it's in GitLab. So for that we have this push button here. I'm currently on the master branch because we can push branches separately, and I want to push the master branch. That's another nice feature. You can locally on your copy of the repository work in a separate branch, try something out, keep it completely locally, and if you're satisfied with the results, you can merge the changes into your master branch and only push the master branch up to the server and keep the server basically cleaner. But you can of course also push other branches up to GitLab. There's no restrictions whatsoever. So I click the push button, and now we can select what branches do we want to push. I let this on the master branch only, and we need to figure out, here you could enter a name of the remote branch. SourceTree, strangely enough, doesn't have master branch on the GitLab server yet, which is kind of strange, but I can click the push button, so I think will be fine. What's important to know is this origin here. Origin is the name of the GitLab server, or the reference of the GitLab server in this repository. You can actually connect to multiple servers that somehow do Git repositories. Has to be a GitLab server. You could, for example, have a second server called GitLab or work or public or whatever. You can choose the origin, the remotes are they called, yes. So you can add multiple remotes to one GitLab repository and push them to multiple servers if you need to. Most of the time you will only have origin, which represents the GitLab server. Okay, so we will push that. This should automatically create a origin master branch. Right, so here we see that the GitLab server now has, because remember GitLab server equals the origin remote, this here has also a master branch now and is on the same state, on the same page with our local master branch here. So if I were to add another change, let's quickly do that. You don't have to do that right now. Like replace this exclamation mark with something else, and I go into file status, stage the readme change, fix typo, commit that, and go back to history. Now I can see that my local master branch is no longer the same as the origin master branch, because the origin master branch is at outdated state. If I now go along and push this again, now it has the master branch in it. Push this again. Now I'm basically bringing the GitLab server up to date with the new version. So, and now if you go to your GitLab page, let's go to start page here by clicking the logo and selecting the project. Now there's something in there, right? So now we have here a list of files, and there is also under repository commits, there is the history of commits that I added, and you can even click one of them, like this the latest one, and then you get an overview of code changes. And here's where it gets really interesting. I won't get into that right here because it's not that important right now, but if you have multiple people working on the same project, you can invite them, you can grant them an invite them to this project, and they can look up those changes, and they can even leave comments on this stuff and ask you questions, so you can clear things up and stuff like that. So it's really neat. GitLab itself has a lot of stuff to explore, which we won't do right now, but all that we want right now is an online copy of our source code. So even if your laptop or computer burns to the ground, you will still have an up-to-date copy of your source code in a private repository on an online server. So you don't need to be afraid to lose anything of your work. Okay, so that's that. Now we'll do a short bathroom break, and then we will get into debugging Python code. So, see you in a second.
In Stereo Podcasts.
Okay, guys, any questions so far? You can, of course, hit me up later. Okay, awesome. Yeah. So now let's go finally to Python, because now we have source control, source code version control, we have an editor, we have a clipboard manager. Now it's time to get finally something in code. Okay, so Python, yeah. One of the most annoying things with Python, in my experience as a simple PC user, is version conflicts. I don't know if you guys ever had this, but sometimes you would get an error, especially on Linux, where an object can't be installed because the versions clash and the system says, I'm sorry, but this version of the Python package XYZ isn't compatible with whatever Python version is currently on your system, or stuff like that. And to not even get into this problem, I looked up how to create what's called virtual environments, which basically means when we create a Python project, we will initialize something like a sandbox where we put our Python interpreter into, and all the packages in the right version that we need for that particular project. That means everything outside will be kept clean and won't get into any version conflicts. This takes a little bit of extra effort, of course, managing those virtual environments, and it's a little bit of command line magic that we will need to do, but it will save our asses probably sooner or later in the long run, so that's why we will go with that. And Anaconda has this neat little tool included called Conda, and that is used for, or that can be used, there are others, and that can be used for managing virtual environments. So I just need to look up the link for this. I think, yeah, I got this here. Let me just quickly enable the clipboard on my virtual machine so I can... Oh, it's already in there, okay. Oops. There you go. Cancel. So, is that the link? Ah, it won't work. What's going on? Copy. Ah, god damn it. Okay, we'll Google it. So, let's see. Wait, where's my dashboard? There we go. Okay. What's the name of this again? There it is. Conda Python. Environment. Let's see if I can find this here. There it is. I will try to post this link in the Twitch chat, or even better, I will put it into the Google Drive document. How to manage virtual environments. So if you take it the Google Docs document, the Python beginner installation notes, and under the Anaconda section, under the download link, there is the link to this article here. And this has a nice introduction into how to use those virtual environments. So first off, we will need to use the right kind of command line, because if you open your command line, your Windows command line, the Conda command won't be available, except you enabled the special option for it in the installer. But if you go here into the submenu and type in Anaconda, then you should find the Anaconda prompt. Open that up. God damn it, Windows 10 search is so slow. But there it is, and this has this special little word base in front of it, and that means that we are currently in the base environment. We could use that, but we will use we will create a dedicated environment for our project. First, we need to change into the directory. For me, that's under documents / tutorial, I think, yeah. And now we use this command here to create a new environment. Conda create -- name, and now we name the environment. We can call that however we want to. Tutorial, for example. And now we need to tell it what type of version of Python we want to put into this environment. Let's go with 3.7. And I forgot what the Y parameter is. Probably just accept some kind of prompt here. So now it will set everything up for us, and I think also download stuff. It breaks my heart how slow this Windows runs in this VirtualBox. On my Linux system, this is all done in no time. Okay, cool. So now we I think we are good now. If we go back into Visual Studio Code, we should be able, when we click down here on this Python version here, then here we get a list of all the Anaconda environments available, and it currently doesn't show the new one. So I had this in the past, and I have to look up if there is a Anaconda. No, there's nothing. I think what worked for me is reloading VS Code, which is, I don't know in which menu that is. I would just use Ctrl-Shift-P and type in reload. Oops. So reload window. Let's see if that fixes stuff. Ta-dum. I'm waiting for the Python version to appear again. Somehow it doesn't want to. I had that when trying this out, and it's a little bit of an annoying why it won't pick up on the new environment. Seems like it didn't like that, so I will just close VS Code and open it again. Then we will try again. VS Code should remember what folder was open last time, so that shouldn't be a problem. So maybe it helps if I open the Python file. Oh yeah. In case you got the same problem, open a Python file, because then Visual Studio Code will pick up on this project being related to Python and will show this again. It still doesn't show it. Okay, so maybe we have to activate it then first. There was, yeah, this command here. Just copy, paste that. Let's see. Okay, now we got that working. Now we got it. Okay, that seems to be the solution. You have to activate it once and then it shows up. Okay, cool. So to repeat, you create the environment with this command line, and after that you activate it with conda activate and name of the environment. So, and now we can switch the environment here to tutorial, which means Visual Studio Code will now use this sandbox environment for this project. If we install any packages, they will all live and only be available inside this project folder. So everything outside on the system will be kept clean, which is really nice. So now there's a nice feature about VS Code, that is it auto detects if you have a Python file open, and it recommends to install stuff. For example, Pylint. We want to install this. Pylint is a linter, and a linter is a general term for a program or a package that looks at your source code and tells you about any syntax errors beforehand while you're typing, so you have an easier time to find errors. So now ask me which package manager I want to use. I will go with Conda here. Conda is a package manager, so it's not only used to manage environments but also to install Python packages that we can use in our project, and Pylint is one of those packages. You can also use pip, it doesn't really matter. So I will just use the Conda one, and it should now pull up a terminal. Oh yeah, and there is some step missing to make this work here. We will have to look up something here, because I think there is some setting in VS Code. We have to tell it to use the Conda shell, I think. VS Code Conda. Anaconda. Conda, yeah. There is a nice article for VS Code. Okay, here select and activate environment. That is what we did by clicking on the bottom left Python version info tag there. Okay, terminal. Yeah, you can do it in the Conda terminal, but we will have to figure this out eventually, because we won't be able to debug the Python code otherwise. VS Code needs to learn how to use our Conda environment correctly. Choose a debugging environment. After using except maybe it will pick up on the environment anyways, because we are able to tell him which interpreter to use. Okay, so where's this? Can we activate integrated terminal? See integrated terminal configure for how to change the shell. Okay. Windows. So shell Windows 10 manual by terminal integrated shell. Okay, let's see if we can find this. Settings, Control-Shift-P, and then we open the preferences. Oh no, settings. Which one is this? Is it? Oh, wrong one. Preferences. Oh man, what's English word for this. How are you guys calling this? Open
So this is
settings,
all for
UI,
today.
open
Hope
user
you guys enjoyed the
settings,
set. See you next week with another episode. Don't
workspace
miss it.
settings,
Mucho
user
love. Nos
settings.
vemos.
Okay, this looks good.
In stereo. You're listening
Search
to
for
In
shell,
Stereo with Juice and Ceballos.
terminal, integrated terminal. Integrated automation shell. Which one was it? Terminal integrated shell. Let's see, VS Code, Anaconda shell. How to activate, yeah. Coding is all about Googling the right stuff. Okay. Yeah, we already did that. We activated it. Okay. Shell arcs. Okay. Let's try this. Settings JSON. If this works, I will just copy paste the right stuff in the Google Docs file. So and now we need to figure this path out here, I guess. Anaconda is installed in C program files. Nope. Nope. Anaconda free. It installs in the user directory by default, it seems. What kind of I'm going to recommend to set your integrated terminal to your default. To that could set. Oh yeah, that's a good start as well. That path should be the same for every system. I want to know how far we get with this. So let's. Yeah, let's try this again. I don't know which one it will pull up. The wrong one. Let's exit this one. Probably have to close the Python file and open it up again. I think I got it. Yes, that's it. Okay, the whole secret to this working is making sure that Visual Studio Code doesn't use PowerShell, but the classic CMD shell for Windows. So all you have to do is to put this in your settings JSON file. I will paste that in the chat fully. Yeah, no, looks fine. And you have to find the settings file, of course, which you can find it by hitting Control-Shift-P for the commands option, search box, and then you put in settings, and there is this preference open settings JSON. And then you get exactly that file, and you simply paste this, the content of what I posted in the chat into here. Let me know when you get it, when you finish that up. Thankfully, this has only we only need to do that once, so because that's now general setting, so for any new project you won't need to worry about it. If you have that's fine. If you have an additional one, you can just put only this part without the curly brackets. Yeah, you can put it underneath or on top. Just make sure that it's inside the curly brackets. So if you got this here, right, so you would need to make sure that it looks like that. Yeah, make sure that you don't have a comma at the end of the line, because this will probably fail then. Okay, cool. Now you close the main Python file and click it to open it again. Then it should bring up the little prompt on the bottom right where it asks for the pylint package. If you still have the terminal open, the PowerShell open, close that by using this trash icon, the kill terminal button first, or it will try again to use the PowerShell. So click this and close here, open that again up, and then it will show the prompt. Click install and then it should work. I hope you made sure that you are in the tutorial environment. Let me know if it works. No prompt. Oh, yeah. For you probably because you tried to install it manually in the Anaconda prompt, right? Then it's already present, the package, and it won't ask. But it should work for future packages. Yeah, okay. So that should be fine then too. Okay. Now we can try to make the debugger work. So we need some. Oh, now it appeared. Okay, cool. Now let me know if the installation now works. Hopefully. Works fine. Thank God. I was really worried. Okay, cool. So now we will finally get to debug something. So we would need something to debug, actually. Yeah, what should we do? Like define a variable or something? Like my value 1 equals 10. And then in the next file we do print my value, something like that. Save that. Oh, see, then here is where the linter comes in, because it warns me with the little squiggle line under the variable that this variable isn't defined. Also, you get auto completion, you get documentation when you click the little I behind here, so that's really neat. You get documentation for the arguments that the commands, the methods know or need, and that's really nice. So everything you need for productive work here. Okay, and now we try to run this. For that we can go to, or we can click on this little play icon on the top right, and it should bring up a terminal where it executes the program, and we get our output of 10 as expected. Is that working? Awesome. So, and now to debug. Let's do a little bit more. Let's do my value 1 equals my value 1 times 2, for example. So, and now to debug, I think this even works right out of the box. So we will just set a breakpoint. This is basically we tell the Python interpreter where it should stop and give us opportunity to look into what's happening. So I will just go with the mouse in front of the line numbers, and there the red dots appear, and click on line 2 to set a red dot. And now I go to debug and start debugging. The shortcut for this is F5. And let's just try if this works. Oh yeah, now it detects that it doesn't really know what kind of debugging it should do. In our case, we have a Python file here. So there are presets for other types of Python projects like modules, remote attach if you run Python on a remote server, Django and Flask, which are and Pyramid, which are all free web application frameworks, so you can build APIs. For now, we are just going to need a Python file. You just click that, and it will set the stuff up, and then it should be running. Yeah, there we are. Now you can see we got this little yellow icon here, which arrow here, which tells us at which line the Python currently stopped, and we can look into the values on the left side. It automatically activated this debugging view for us, and here you see the value of our variable my value 1 with 10 currently, and the built-in variables which can expand or collapse. Yeah, and to step further in the source code, you can use these icons here. This one is just continue, which means just continue running without stopping until the next breakpoint comes. So you can basically jump between breakpoints, or it will run to the end if there is no more breakpoint left. And you got step over, which is what you would use most of the time. That means execute this line of code where you currently at, and wait at the next line. Step into and step out is if the source code is about to call a function or something. Basically jump. If it would jump to some other place in the source code, some subroutine or whatever term you're familiar with, then it would jump into that instead of jumping over it in the next line. So you can go deeper into the source code. Just experiment with that. You will get what I mean with that by just debugging your code. And then there is step out. If you would stop your source code inside some function that you defined with step out, you would basically run that function to the end, and then and then the interpreter would halt right after that function is stopped, and you can step further one layer above, so to speak. So, but just experiment with that, and we will probably use it in future streams as well. So, and then last but not least is restart and stop. So restart does what it says. It simply restarts the whole script from from top, and stop is just cancel and don't execute any further than here. So for now I will press F10, which is step over, and we will watch what happens to the left side. So we made one more step, and it executed this line, and now we see that my value is 20. So this is called the inspector. Here you can nicely see what's going on in your source code. This is really useful. So there is also something called a watch list. Here you can add expressions like my value 1, and then it will always keep you updated which value this variable currently has. You can even add an expression in there, like a whole code statement where something is actually executed. But this is really useful if you have hundreds of variables. Then you can pick one or two, or however you need, important ones out of there and add them to the watch list, and you can always see what's the current value on them. That can be very handy. We can edit or remove the expression from here again. And then there is the call stack. The call stack is basically the history of the way the code was stepped through. So we would probably need to do an example for this. So we will in a second just let this run through here completely. So we got our output here, and now we will define a function and do something in this function. I hope I can do that from heart, to be honest. I think it's dev, and then we need a name, multiply, and then we give it two params. I actually have to look it up. As I said, I'm a Python newbie myself, so I don't have to try to figure out the syntax for this. Python example. Yeah, okay. So it takes a value, call it val, for example, colon, and here we do val equals val multiplied by 2. And how do we return something? Oh yeah, with return. That's easy enough. Oops. Return val. And yeah, that's that. Now we can remove this. I hit Control backspace to delete this. And we move that down with Control and the arrow key down. Already gets useful, right? It's already useful, this stuff. So And now we will call our function here. Let's move this one down here as well, so the method is on top. And we do my value 1 equals multiply, and it takes one value, and we put in 10, so we don't even need that one anymore. And here we print my value 1. Should be easy enough. Okay, so let's run this in the debugger and step through it. See if I did something stupid or if this works. So I press F5, run this as a Python file. Okay, now it stops here. And now we are here where it's about to call this multiply function, and I want to step into that multiply. If I, for demonstration purposes, maybe here to see the difference, if I use step over, it would just jump to print. It basically stepped over that function call. It executed it silently and paused at the next line of code, right? So now let's restart the code. So now we're here again, and now I use the step into, and now we should, yeah, and now we stepped into the multiply function here, so I can get deeper, like more fine-grained stepping through the code, right? Often you simply want to step over because you know what the function is doing and you're not interested in debugging it, so you can just step over. That's why I said F10 or stepping over is the most commonly used one, but step into is handy as well oftentimes. And now I can use F10 to see how val is changing, and now val is returned, and F10 again, and we stepped out, and now we're on the print function, and here we can see my value is now 20, as it should be. So that's the difference between step over and step into. Make sense? Okay, cool, awesome. Yeah, and that's actually it. I think there is a way to get rid of this of the prompt here every time you hit F5 to start debugging, so you don't have to tell it every time that you want to debug a Python file. You can also create a launch JSON file here to fix that, or to make that persistent. Let's see, this one just does this. I just have to figure out which one that was. I think we have to use that link here actually. Yeah, okay, we click create a launch JSON file, and then we tell it Python file, and now it created this configuration for us, which is, by the way, added to the project directory here under this .vs code file. There is also the settings JSON file for the Python exe. Oh, this visual debugger is hell of a lot better than the crappy text version of Spider. Yeah, that's probably true. Visual Studio Code does a very good job with the debugger. I use it to debug my JavaScript code, and it works very nicely as well. You have to be careful when you add that the configuration for the command line, that you didn't add it just here in this settings file in your in your project directory, because then the setting would only apply to that single project. So make sure that you edit that setting for the command line here in open preferences, open settings, because as you can see, that's a different settings JSON file than this one, right? Just maybe be aware of that in case the next time the whole shenanigan starts again here. That file lives, by the way, under app data roaming code user settings JSON. So just as a pointer, so that you know you have the right one. Okay, so but now we have this launch JSON file, and now if I press F5, it shouldn't ask me anymore what I want to debug. It just knows because the JSON file is present, and it simply starts debugging. So yeah, that's that. On the bottom left, there is also a list of breakpoints. So if you would set multiple ones, they appear here with the file name and the line number, and you can pause or disable or enable single breakpoints. If you want to keep them, but you don't want code or the debugger to stop there right now, currently you can use the checkbox. You can remove them here, and you can also remove them here or toggle them by clicking on the red dot again. And there is another neat feature that is very useful. You can actually have conditional breakpoints. That means you can make sure that the debugger only stops at a certain point in the code if a certain criteria is met. I will show you what I mean with that. So let's call this function again here. Oops. Control D to duplicate. And second variable 100. Save that. So, and now let's say for some reason I want the debugger only to stop here if val has a value of let's say 10, not if it has anything other than 10, like 100. So for that I can use a conditional breakpoint. I do, instead of a left click, I do a right click here on the red dot. I say add conditional breakpoint, and then I have to put in a statement, like an if statement. For example, my val equals the double equal sign 10. So now we get a red dot with two very tiny black bars in it. And if I run the debugger now with F5, hopefully it should only stop when value is 10. That's right. Oh yeah, by the way, if you hover over the name of a value while debugging, it shows the value in the tooltip, and you can also see it on the left side. So okay, cool. Now it stopped now when val was 10, and now I will continue by stepping over. So, and now we are here where it would call multiply with 100. And if I now press this continue button here, where it would stop if there comes the next valid breakpoint, then it would stop here, but it won't because the condition isn't matching. So here we will see that it is not stopping because here val is 100 and not 10, and that's why it's not breaking here. Make sense? I did a crappy job explaining that, but hopefully it got through to you. Okay, so and these expressions, of course, can be more complicated. You can also do val equals 10 or val equals 100. So if I remembered the syntax correctly, you should now stop at 10, and if I continue here, it should stop again, and now at 100, because both conditions are okay for the breakpoint. Okay, so let's stop this. Remove the breakpoint. Okay, yeah, and that's the basics of debugging Python code. You should already be able to see that this is most of the time much more useful than just slapping in 1,000 print statements to keep track of what's happening in the code, right? I'm not gonna lie, to this date, I'm using I'm using output statements myself to keep track of code, but the debugger is just better suited most of the time for this stuff. Yeah, I figured you would probably do that because everybody does, especially if they're a beginner. So yeah, last but not least, what I want to show you, but not get into too much detail, is the Jupyter notebooks. That comes for free with the Python extension that we installed for Visual Studio Code. And you can create a new Jupyter notebook by simply hitting Control-Shift-P for command, and then Jupyter, and there should be a menu point called Python create blank Jupyter notebook. So I click that, and now I get a new tab, so we can pull that command line just down here, like so, drag and drop that down. Now we have here a Jupyter notebook, and Jupyter notebooks basically are a nicer way to prototype stuff, try stuff out, and manage your code. You can put in source code here in what's called a cell. These boxes here are called a cell. Like for example, what we had before with my var1 equals 10. And then I can add another cell, and here maybe do something like my var 10, my var1 equals my var1 times 2, and we do, of course, we can do multiple stuff. This can be whole code segments with functions and everything that Python offers. My var2 equals 100, and we do another cell and do my var1 equals my var2. So probably the most useless code ever. So and now the special thing with these Jupyter notebooks is you can run those cells separately, or really in any order you want to. So I can go here and click this run all cells button, and that just runs the whole code at once. It takes a little bit of time, especially on my VirtualBox machine here, to start this Jupyter notebook server thing here. So the first start is a little bit tedious. Yeah, come on. I will probably explore the concept of Jupyter notebooks a little bit more later on. I'm more a classical coding type, so the Jupyter notebooks are cool for prototyping for me. I don't know if I would necessarily build a whole project for it. I could imagine that it's doesn't work. Yeah, I can't using closest match instead. Error. Module notebook is not installed. Maybe we just need to install the module. What is doing? I missed the message on my machine. Probably said the same thing. It won't give up. Okay, let's pull up our command line here and see if we can fix that. So you would just place your mouse cursor over here, the bottom bar here, where it does the resize cursor, and then drag upwards. Click and drag. Let's use Conda. Did mine run now? Let's see. Yeah, mine did run. Yours didn't. Module notebook is not installed. First of all, make sure that you have the same environment selected as I have, the tutorial Conda. Do you have that? Okay. Maybe it has to do something with yeah, let's just try to install it. I think it's Conda install and then notebook. Proceed. Let's see if that breaks everything for me or if that fixes everything for you. For starters, we would just do what your error message states here, and that is module notebook not installed. So we'll just install it and see what happens. Come on. Okay, in the meantime I will save the Jupyter notebook because it's currently still an untitled file. Control S, and then we'll put it into the source code folder and we call it notebook dot whatever that is. Save. There it is. Okay, it's done. If you did that, maybe try again to run the cells and see if that works. For me, it works fast now because but it did before. Let me know if it now works for you. Hopefully. Set it from tutorial Conda. Oh yeah, you have that environment enabled. Using closest match, base Conda. Works. Okay. I have no idea why you had to install the notebook package manually, but okay, now we know. Maybe VS Code does it automatically when you when it itself activates the environment. That's maybe the case because it knows that it is capable of doing notebook stuff, Jupyter notebook stuff. So maybe that's the reason. Okay. So now when you run this code, nothing really happens here, but we can inspect the variables by using this little icon here. It's the third from right, and its tooltip says show variables active in Jupyter kernel. If you click that, you get this little table where you can see all the variable values currently assigned. So now there is some stuff you can do with this. First of all, you can where is it? This one, I think. You can clear all the output. So oh yeah, we get this again later, and we can restart the IPython kernel. If we do that, it should restart the whole notebook. So this is empty as well. Just have to confirm here with yes. That's like when you need a complete new start. Okay, and now we see there are no variables defined, and now here's where it gets funny with the stuff. You can run cells individually, so you can click on the first cell on this play icon, and then it runs this, and it only executed this. That's why you get this one here, right? And you see the content, and then you can click the second one, and it will run the second one and update the stack here, and then the third one, like that. And now you can do funny stuff, because now if you run a cell that is in the middle of the code again, it will apply the operations from that cell to the variables again. But the stuff before and after won't run. So if I click that again, as you can see, we now doubled my var 1 again with the value 100 being applied to it beforehand from the third cell. So you can see we ran those cells out of order, right? You can also see that here with 1, 3, and 4, which ran at what time. You can also tell it to you can click a cell and then tell it run from the current cell and everything what's below. So it can run this cell and this cell only, but not the first one. And that's why we get this output all of a sudden, and you can only run the current cell and everything that's above. So now we basically ran it backwards. So, and you can move the cells around. So you probably get the gist. This is really nice to experiment with different type of stuff, but I think it's also pretty easy to trip yourself over if you manipulate variables in the wrong order. So to run this, to bring this back into clean state, you can simply run all the cells from top to bottom with this icon here, and now you get the expected results. Yeah. So you can see this here. This is kind of like a counter how often the cell has run, and you can clear all this up here with this button, and now it reset this, and you can run them again. And now, oh no, the output button is for something else. Oh yeah, as you can oh, that's probably because if you have something like print var my var1 and I run that, I get that output, and this probably deletes the output here. Yeah, that's what it's for. Okay. Yeah, so that's the very brief introduction into Jupyter Notebooks. I have to explore this myself much more, as you can tell, but yeah, that's what I got so far, and I guess that's a good start to experiment with it a little bit more. But I really want to focus on working with Python, so in the next stream I want to go through the basic parts of the Python language how to do methods, how to do if statements, loops, how variables work, arrays or lists, and all the good stuff, all the little building blocks you need to actually write something that produces something useful at the end. Yeah. So, do you have any more questions? Because otherwise I would cut the stream right here, and yeah, we'll call it a day. Okay, awesome. So the last thing we have to do is save our Jupyter notebook. Control S, go into our SourceTree window, switch to the file status, and here we will commit everything that we changed so far. Stage all, simply shortcut to put everything in here. And result of the first stream. Okay, commit that. Back to history. Here we got that, and now we push that. Push to the master branch on the GitLab server. Yeah, and now the GitLab server is up to date with our stuff, and I can't lose anything. Okay, man. Thanks for watching, guys. And yeah, if you have any questions, hit me up on Twitter. If you have any suggestions, oh, there is a question. What happens if you save your file in VS Code but don't commit? Nothing really. The file stays changed on your machine. It's simply, yeah, and it stays locally. So Git doesn't force you to do anything. It's totally up to you to keep your changes committed. I would recommend to commit at logical states, like if you have something finished, a little part of your project, where it simply makes sense to gather a point in history, commit it in your repository because it's a logical unit of your project. Yeah, then I would commit, and at the same time it's kind of a offsite backup, right? If you push it to your GitLab server, you don't have to push it. I sometimes have the bad habit to work for weeks on my projects locally and commit them locally to my Git repository, but I don't push them to my GitLab server, which isn't really good practice, because if my notebook breaks, then I could lose some of my work. I also have an external hard drive where I do backup on, but yeah, still it lets me sleep better at night if I know my source code is also on a server in a professional data center where it is safe and secure. Yeah, so to sum up, nothing really happens. It's up to you. All the Git stuff is completely optional. You can code without using Git at all. It's just an add-on. Okay, cool. So yeah, I will end the live stream right here. And if you have any questions, hit me up on Twitter. If you have any suggestions, also hit me up on Twitter. And with that, I wish you guys a great day, night, morning, whatever you have right now. And yeah, see you next time. Bye.